Intercontinental ballistic missiles, or ICBMs, have been the backbone of US defense since the Cold War, designed as a deterrent against the threat of nuclear war. Originally, the Minuteman III ICBMs, deployed in the 1970s, were expected to serve for about a decade. Fast forward 50 years, and the US is still relying on these aging relics for the bulk of their nuclear strike capability. But the clock is ticking. These old warriors are showing their age, facing more and more launch issues. Imagine a scenario where, at the moment they were needed most, they flop. The result? A potential nuclear crisis where the US could be caught flat-footed, giving the upper hand in a global showdown to most likely Russia, the nation with the world's largest stash of nuclear warheads and a penchant for rattling the nuclear saber. So it's crunch time for the US to revamp its aging arsenal. Plans are on the table to update the ICBM network, but they're not without their own set of challenges. Let's dive deeper into why these missiles are so critical to US defense strategy and what's at stake if they don't get the upgrade right. Ever since the 1940s, the scope of the Manhattan Project and the effects of the nuclear strikes on Hiroshima and Nagasaki have emphasized the need for complete nuclear coverage. The US could use its superior economy, technological advancements, and military size to create an effective nuclear stockpile that would deter the Soviets from launching a nuclear attack. To ensure the US would stay vigilant against the rising nuclear threat, it devised the US nuclear triad in the 1960s through a combination of ground, sea, and air forces. Each part of the triad fulfills a certain goal. Let's start by taking a closer look at how the US has leveraged its air capabilities to reinforce its position as a nuclear superpower, starting with the legendary B-52 Stratofortress bombers and the stealthier B-2s, which carry the legacy and lethality of American air power into the future. The B-52s are large, subsonic aircraft that can carry multiple nuclear warheads and have seen extensive combat use over 70 years of service, even if they have only used conventional bombs so far. Their relatively low operational and upkeep costs mean that they're projected to be usable well into the 2040s. As a result, they exude a significant presence of the US Air Force, assuring allies that the US can meet global security needs. In contrast, the B-2s have more flexibility in how they can be used, launching devastating precision strikes deeper into enemy territory. Thus, the combination of low-cost, broad-use aircraft and high-cost precision bombers ensures that the US can field offensive aerial capabilities with 60 plane-deployed nuclear missiles and gravity bombs. While the B-2 bombers carve paths through enemy airspace with their precision strikes, the real under-the-radar power floats silently beneath the waves. Picture this: 14 stealthy ballistic missile submarines, each armed to the teeth with 240 nuclear-tipped missiles, silently patrolling the global ocean depths. These hidden behemoths are nearly impossible to track effectively, turning the vast oceans into a mysterious chessboard where the US holds some powerful, unseen pieces. These submarines aren't just about firepower, they're the backbone of the US strategy to ensure a constant state of readiness. Thanks to their stealth and mobility, they can lurk undetected thousands of miles from home, ready to respond to threats at a moment's notice. The submarine-launched ballistic missiles have ranges in several thousands of miles. This makes them perhaps the most enduring piece of America's nuclear deterrent, a true force to be reckoned with hidden beneath the ocean's surface. And the last leg of the triad is the ICBMs. The land-based nuclear missiles are concentrated in 450 underground missile silos located in 5 states in the US heartland: Colorado, Wyoming, Nebraska, Montana, and North Dakota. The 450 silos contain 400 ICBMs on active duty and another 50 in reserve. The silos are designed to cushion against enemy bombing, ideally requiring at least 2 nuclear warheads to penetrate and disable the launch system inside. The states that the silos are in have been carefully chosen due to their relatively low population density and lack of significant cities around the silos. If the silos end up being bombed with nuclear warheads, the life loss would be minimized to a few million people, giving the rest of the US more time to take defensive measures and mount a counteroffensive. Land-based ICBMs have nearly unparalleled speed and range, capable of reaching halfway across the world in under an hour. This makes them the country's primary way of making sure they can exert geopolitical and military security influence. The ICBMs can be used in a preventative attack, striking the enemy nuclear missile silos and key strategic targets before they can mount a successful defense. This has resulted in nuclear-capable countries adopting the doctrine of mutually assured destruction. If someone attacks with a nuclear weapon, they'll receive the full force of enemy nuclear warheads to annihilate remaining offensive positions. It ensures that nobody wins the nuclear war per se, which puts countries on a relatively even footing. However, this has created an uneasy peace between NATO, since the US, the UK, and France all have nuclear weaponry, Russia, which has the largest nuclear warhead arsenal, and China. Since giving up access to nuclear weapons altogether means that the countries would lose the ace up their sleeve, neither of them has been willing to completely abandon nuclear weapons projects. And while the various nuclear non-proliferation and disarmament programs have greatly reduced the sheer volume of nuclear weapons from over 78,000 in the 1980s to 12,500 today, there is still mounting tension of a possible nuclear attack in the light of rapidly deteriorating diplomatic relations between the world's major powers. Add to that the fact that the US has expended significant effort in modernizing the land-based ICBMs, and the warheads and bombs themselves are much more precise and deadlier. As mentioned, the Minuteman III missile was designed to be operational for 10 years, and they have been the US's primary land-based nuclear missile since 1970, with the last such missile produced in 1978. Since then, the US Air Force has slowly reduced the number of missiles it can operate and added more modern navigational systems to more recent missiles. But the missiles have already started to show their age. In July 2011, during an unarmed test launch to verify a missile's operational capacity, one Minuteman missile was destroyed shortly after launch due to widespread system failure. A more recent test in November 2023 also resulted in failure, prompting the US Air Force to detonate the unarmed missile over the Pacific Ocean and destroy it before it could go off course. With the aging systems and structural support for these missiles, one of the legs of the US triad could give away at a crucial moment, decimating the country's capability to respond to foreign nuclear attacks. The declining operational systems of the Minuteman III prompted the US Air Force to seek future-proofed missile development programs. The winning solution, the Ground-Based Strategic Deterrent, GBSD, later renamed the Sentinel program, is considered the single biggest investment in national security since the Eisenhower Interstate Highway System. The initial project cost of the Sentinel program was around $100 billion. The Sentinel plan aims to build 659 missiles and upgrade all 450 silos across the US West, as well as their surrounding communications and support infrastructure. The new Sentinel rockets will be built from reinforced carbon, which is much lighter and more durable than the steel used for the Minuteman designs. The newer missile design also allows the missile systems to be more readily upgraded to maintain their operational functions for roughly 50 years, compared to the estimated 10 years that the older designs were made for. However, the program has hit multiple snags, with the Air Force recently announcing that the initial development costs would rise to roughly $130 billion, with some more grim estimates reaching as much as $150 billion. The budget overrun has triggered the Nunn-McCurdy Amendment. The amendment essentially terminates any government-funded weapons procurement program that goes between 25 to 50% over budget, based on per unit or total costs, unless the Secretary of Defense submits a detailed explanation of the necessity of the program and the stability of the new estimated budget. While the amendment has never actually cancelled a government-funded program, it has caused numerous changes to project management and development. For example, the US Navy Zumwalt-class destroyers rose in costs steeply, which triggered the amendment and ultimately brought the number of ships built from 32 to 24 to 7, then to only 3. While the program is undoubtedly one of the most vital defense programs of the 21st century, it's unlikely to escape the Senate without any meaningful changes that ultimately affect how many Sentinel missiles are deployed or the extent of the silo upgrades. And while the deployment of the missiles themselves is largely a question of technological alignment, production capability, and supply chain dependencies, the actual problem surrounding the program mainly lies in the launching silos. Originally designed shortly after World War II, the 450 distributed missile silos have primarily analog communication and launching systems. The silos themselves also contain a distributed network of thousands of miles of copper wiring and fiber optic cables surrounding them, as well as roughly 7,500 miles of utility corridors, which are used to monitor, control, and communicate groups of silos for a concerted defensive and offensive effort by the US Air Force. These wires are basically the systems that allow the entire US nuclear warhead stockpile to be launched in quick succession, overwhelming the enemy with 400 ICBMs and their payloads. The analog nature of the communication systems has a few advantages over more modern systems. First, it's relatively easy to maintain and detect faults in the system, and any errors in the system typically have redundancies that make sure the entire launch can proceed as normal. But perhaps more importantly, the wires are virtually inaccessible to enemy cyber attacks. Enemy agents would have to physically intercept the communication system at ground level, which would be a remarkable feat given the security levels surrounding them. This means that the existing system is potentially more impervious to enemy digital warfare than the proposed new system. Digitizing the system would open the door to more potential lines of failure and cyber attacks, which only heightens the cost of implementing sufficient security measures to mitigate them. Additionally, the surrounding infrastructures have fallen back over the years due to being built on private property. As a result, the Air Force needs to purchase this real estate to perform the necessary upgrades and replacements. It further increases the overall cost of the system and makes it less likely to properly estimate the total budget and feasibility of these changes. Finally, there's also the matter of ongoing maintenance and future upgrades. According to the Pentagon's estimates in 2024, the cost of the next-generation Sentinel program could be as high as $300 billion over a 50-year life cycle. The mounting costs have some experts worried about the necessity of the land-based Sentinel system. They're taking the words of the first START 1 nuclear non-proliferation program, "Nuclear war would have devastating consequences for all humanity, it cannot be won and must never be fought," to the extreme. The perpetuating rhetoric is that the Sentinel program only presents a bottomless budgetary pit that would periodically get filled from the same budget that vital healthcare, education, and infrastructure initiatives could use. Additionally, the silos that house the ICBMs are typically considered the first targets for a nuclear strike, putting millions of people in danger from potential radioactive leaks. Even if the dread of nuclear war remains just a shadow, the old silos could still spell trouble. Imagine a scenario where these aging relics fail not due to war, but to wear and tear, threatening the safety of neighboring communities. Critics argue that investments like the Sentinel program primarily line the pockets of the defense contractors and those who manage these sites. They propose a radical shift. What if we repurpose these Cold War-era sites into hubs of innovation like engineering and research campuses, boosting local economies and fostering technological advancements? The argument against the land-based leg of the nuclear triad grows stronger considering the prowess of the US's sea and air capabilities. Why stick to old methods when submarines and bombers offer such flexibility and strategic depth? These mobile platforms not only enhance America's defensive posture, but also allow for precise and decisive action from a distance. Advances in submarine-launched missiles now equip them with a reach and accuracy that rival their land-based cousins, turning these stealthy behemoths into guardians capable of deterring threats from oceans away. However, the reality is that the ICBMs can take the load from the other triad security measures. Currently, the Minuteman III missiles are loaded with only one nuclear warhead, whereas their maximum capacity is 3. As such, the existing system is highly flexible to allow for precise targeting in case of a limited attack, a much more likely scenario than all-out nuclear bombardment, while also being able to scale and fully load up to deliver a devastating first strike. Secondly, the fact that the silos present an immediate threat to an enemy willing to use nuclear weapons means that they'll be the first target in a nuclear war. Considering that the silos are currently cushioned and defended against attack, the enemy might need to expend 2 warheads per silo. This means that 900 warheads would already be out of commission from the opponent's side, giving the US a numerical advantage or evening out the odds. At the same time, the robust control centers of the silos are prepared to launch the missiles 24/7. As a result, even if the enemy decides to launch the strike first, the US can likely detect it and strike back with the same force. The 900 nuclear warheads would therefore largely be wasted on empty silos that house minimal staff and don't have large population centers nearby. The cushioning strategy first designed in the Cold War would finally come into effect then, potentially saving millions of lives. Compare this to some of those nukes being dropped on the largest cities and metropolitan areas in America: New York, Los Angeles, Chicago, Houston, Dallas, Fort Worth, Miami, and Philadelphia, and the mitigated damage to population, infrastructure, military complexes, and even reputation is difficult to discount. Without the silos as the first target, the enemy could very well target other military bases that house nuclear-bearing aircraft or go for the major population and industrial centers. In these cases, the US economy and military defense systems would be decimated, with the potential to never get the chance to deliver a counterattack. Perhaps more importantly, these other targets are much more vulnerable to conventional attacks, whether from physical ordnance or cyber threats. Effectively, a potential nuclear-wielding enemy might not even need to exert any of their nuclear warheads to eliminate the US's capability to launch their nuclear weapons. If a complete disarming strike were to happen, the US would pretty much lose any leverage of a nuclear response, and an opposing nuclear detonation would have a similar effect as the American bombing on Hiroshima and Nagasaki, a show of overwhelming force that would immediately put the US out of the conflict on the losing side. Additionally, the ICBMs are designed with a singular purpose: to swiftly deliver nuclear warheads and other ordnance deep into enemy territory. Their function for traditional military missions is highly limited, and proposed strategies to use the rockets to deliver satellites into Earth orbit have never been put into effect. The US is therefore posturing that it's devoting significant personnel and resources into creating and maintaining a deterrent against nuclear threats from other nations. And this shield extends to the US allies such as NATO members. This level of focus is unlike other defensive capabilities of the US Air Force or Navy. For example, the B-52s that can deliver nuclear warheads have already had extensive use in traditional military operations, dropping bombs on Vietnam and the Persian Gulf. Stealth bombers and ballistic submarines can similarly be used in a wider assortment of military conflicts. In the event of a multipolar war that leverages both nuclear and traditional warfare, the naval and air-based nuclear launch systems would need to perform a double duty. Without the ICBMs in place, the US would need to develop, build, and field more submarines and aircraft to fill their nuclear warhead quotas. Currently, the ballistic missile submarine fleet isn't enough to house both nuclear and traditional warheads, so the Navy would have to carefully pick and choose its battles. According to some estimates, it would take the Navy well into the 2040s to obtain the necessary nuclear missiles and submarines to make up for the loss of Air Force ICBMs and still have the capacity to do nuclear-free missions. Out of the 3 nuclear defense options that the US is using, only the land-based silos and the submarines are kept permanently stocked with nuclear warheads. The B-52s and B-2s need to be separately mounted with nuclear gravity bombs and flown over the target, giving them a significantly longer preparation and mobilization time. Without the ICBMs in place, an enemy could focus most of their effort into well-known military aircraft bases, grounding the US Air Force and leaving the submarines as the only responsive nuclear deployment system. The submarines could then be attacked through conventional means of physical and cyber warfare, potentially delaying the US nuclear response for days or removing it completely. Proponents for making the submarines America's primary nuclear deterrent systems are typically quick to point out that there is no current system, technology, or strategy that could threaten the US submarines on patrols. However, the changing tides of the private tech sector mean that a company could feasibly create a method to attack US submarines and sell it to Russia or China, giving a nuclear-bearing country the potential to directly eliminate the sea-based leg of the triad. The US competitors are already pouring significant effort into advancing submarine detecting technology, bolstered by promising advancements in real-time oceanographic mapping and modeling. The dangers of relying on submarines alone have been brought up already by Obama's administration in 2010, and the sentiment is unlikely to change. The Nuclear Posture Review in 2010 was also the key factor in deterring the US government from attempting to further try and maintain the aging Minuteman system and pave the way for launching the GBSD program 10 years later. Opponents of keeping the ICBMs argue that the silos being on a so-called hair trigger alert and ready to launch all available nuclear warheads in a matter of minutes enhances the risk of accidental nuclear launches. They point to the previous history of near misses such as the Cuban Missile Crisis. If the US mistakenly believes that Russia or China has launched a nuke toward US or Allied soil, the launch of warning capability could result in the US using nuclear weapons as the first unnecessary strike. The ICBMs cannot be recalled after being launched, so the nuclear payload will be detonated in one way or another, either in a successful attack or by anti-air measures of the target, making the US responsible for a catastrophic attack before the mistake could be rectified. However, the operational capacity and combat readiness of the ICBM silos doesn't mean that they will be used as such. The current multi-layered procedures required to launch missiles are reinforced with safeguards made exactly to prevent this scenario. As such, the current US operational capacity is similarly meant as the ultimate deterrent for nuclear war rather than a tactic that the US Air Force will use should one come. Additionally, Air Force and STRATCOM, US Strategic Command, leaders have publicly stated that the new and improved Sentinel system will come with more precautions to further mitigate the potential of a mistaken launch. Without these modernization attempts, the existing infrastructure might fail by itself or open the doors for malicious actors to either force a launch or disable the ICBMs before the enemy announces an attack of their own. With all this in mind, the new Sentinel program is expected to proceed according to a modified plan brought by the budget overshoots. The first planned Sentinel ICBMs should be produced before the end of the decade, and the entire project is expected to be fully operational before 2040. This means that the country only has to rely on air and submarine-based defenses for a few years, and the current Minuteman system is expected to still be functional by then. Despite the connotations that the Nunn-McCurdy protocol might cancel the program or heavily alter its course, all previous administrations have recognized the need for a multifaceted triad. This trend is likely to continue in the future, as GBSD has received full bipartisan support. The Air Force would likely just need to ensure that it spends adequate effort in presenting their findings to both the US government and the general public. As the backing party behind two of the three triad legs, the Air Force effectively holds the reins to much of the US nuclear deterrent and air defense systems. This means that the Air Force needs to maintain sustained attention on its leadership, management, and budgetary policies. But in light of the US readiness to improve and adapt to technical challenges brought by the aging infrastructure of the ICBM systems, how likely is nuclear war anyway? The recent events in Ukraine have made the nuclear threat higher than at any time since the end of the Cold War. Putin has presented a nearly united front with China that the West is to blame for the current destabilization in both Eastern Europe and the Indo-Pacific. For that reason, the Russian administration is perhaps the most likely initiator of a nuclear launch toward either Ukraine or a NATO country. Considering that Putin has announced that Russia will suspend its participation in the New START initiative, a nuclear non-proliferation pact with the US, Russia no longer supplies the US with information on planned nuclear launches or military exercises. This lack of transparency means that Putin might be saber-rattling or seriously poised to make concerted efforts to launch a nuclear war after the pact expires in 2026. The world has about 2 more years of relative safety from nuclear war before the US and Russia are forced to reconvene and discuss their future plans. And with the US committed to ensuring that its nuclear deterrence and offensive systems are prepared for an all-out attack, the Cold War might restart, even if only militarily. Meanwhile, China has been making waves in light of its own advancements in nuclear weapons and conventional military. The future of the world is still very much uncertain. But what do you think? Is the US program to improve its ICBM silos and missiles a wasted effort? Should the current or future US administration push more towards complete global nuclear disarmament? Let us know in the comments below, and thank you for watching the video. Now go and check out Russia's top nuke targets, or click this other video instead.